Hi all, my name is Praveen. Welcome to my YouTube channel. Let me ask you something. Have you noticed nowadays everyone is talking about AI agents and something called MCP? It feels buzzword, right? What if I tell you MCP could be as important as HTTP or even USB in the AI world? In today's video, we'll break it down in the simplest way possible. So by end of this video, you will understand what exactly MCP is, why MCP needed, what real problems it solves, how MCP architecture works. We'll also look into MCP transport types. And just not a theory, we'll also write one simple hello world MCP server code, and we'll see how to test this MCP server code locally with MCP inspector and also with Claude desktop. Finally, we'll write a MCP client code and test the MCP client to MCP server communication. So stay tuned with me till the end. It's going to be practical and powerful. Before jumping into what MCP is, we need to understand why MCP even exists. To understand this, let's go back few years. Let's assume you are a developer. Your job is to communicate to different external systems. It it sounds good, right? But here is the problem. There, what if there is no standard? What it means is these external servers, they are not following any standard rule to expose their services. So developer like us has to write custom code to integrate with these servers, GitHub or Cloud Infra or maybe weather report servers. One custom logic to integrate with GitHub, another custom logic to integrate with Cloud Infra, another custom logic to integrate with weather report. Because of this, our code becomes messy. Code maintenance become painful, and also scaling these applications become difficult. Here something happened. Now developer wants to one common way to communicate with these servers. Here comes the HTTPS come into picture. Now these external servers follow this HTTP or HTTPS rule to expose their services. Now developer has to write one common logic with methods like get to fetch the information, post to send the information to the services. Only thing is he has to pass the endpoint details along with the payload. With this, developer can able to communicate to all these servers. Now advantage of this is code become uniform, code maintenance and scalability will become easy. Exactly this idea will help us to understand why MCP needed. Now start with LLMs. What are LLMs? LLMs are large language models. They can generate text or data based on its pre-training data. Let's take one example. If user asking question, explain photosynthesis. Now LLM look into its pre-training data and provide complete content to the user. LLMs have knowledge cutoff. What it means is LLMs trained only on the data available up to this cutoff dates. If you ask any questions during this time frame, they can able to answer the question. But these LLMs are blind to the data generating outside of this cutoff dates. If you ask any question, latest information, real time data or recent events, LLMs can't answer. They can fail to answer or hallucinate. To solve this problem, RAG, retrieval augmented generation, come into picture. What LLMs with RAG, we are providing the domain specific resources access to the LLM. Domain specific resources are documents, PDFs or databases. These resources to the LLM we call it as a knowledge base. When user asks a question, it will look into the knowledge base and retrieve the information and respond back to the user. But LLM with RAG as static in nature. What it means is they can't do any actions. If you want to book a flight ticket, LLM with RAG can't do the task. They can't trigger any events or that. These problems are solved by providing the tools access to the LLM. LLM with the tool becomes a agent. So here, what is tool? Tool is something that LLM can use to perform actions outside its brain. We will understand this with a simple example. When a user asks a question, what is the weather in Hyderabad? That question information passed to the LLM. LLM retrieves, look into the query and understand that it is not into its knowledge pre-trained data. It is outside its intent. So it selects the get weather tool and call that tool. Now tool executes the REST APIs, uh, get the information from the web servers. That retrieved information, it is in a JSON format. That raw data, JSON data, will be sent back to the LLM. Tools will send the raw data to the LLM. LLM, after receiving this raw data, it will convert into natural language and respond back to the user. We'll understand this by looking into code. Now here user asking the question, what is the weather in Hyderabad? That user query along with the tools available, that information passed to the LLM. Here our LLM is Claude 4.5. After receiving the query, LLM selects the tool get weather tool and call the tool by passing the parameters. Here parameters are in input parameters are Hyderabad. City is Hyderabad. Once tools receives the once tool calls execute, it will execute the REST APIs and retrieves the information. That retrieved information will be in JSON format. This that retrieved JSON format data again comes back to the LLM. That LLM convert it into natural response and the final natural language natural response it will store it in the final one and respond back to the user. One thing here we need to note is this LLM along with tool call logic, everything exists inside the application code. That we have to remember here. Let us assume now if our application want multiple tools to perform different actions, like one tool to get the weather information, other tool to fetch the uh, database information, another to send notification via email, like this. Now your tools calls are increasing, right? For that we have to write multiple if else logics like this. If tool equal to weather, call this weather, get weather tool. Else if it is database, you have to call the query data. Like this, if your tools are increasing, our if else logic will increase. And another thing is to call the tools, we have to pass the secrets, right? That secrets also we are defining inside the application code. So it becomes a tightly coupled architecture. Um, Problem with this traditional tool calling flow is this is a tightly coupled and hard coding logic, poor security, and scalability is difficult with this traditional tool calling. To solve this problem, Anthropic comes with the MCP concept. So MCP fixes by moving this complete tool call logic to the its own remote process. That remote process we call it as a MCP servers. Complete these tools logic will be moved from the application code to the remote servers. Here, these are the remote servers. One is weather server, another database server, email server, file server. And secrets also will be defined in its own server. Now, coming to our application code, our application code contains the LLM logic and NCP client code logic. With this, our application communicate to the MCP server using the MCP protocol. With this decoupled architecture, advantages are better modularity. What it means is if you want to add more tools, you can easily add tools in this MCP architecture. Another advantage is no hard coding logic. If you add new tools, just configure the tool name information to this application code, it our application code finally will work with the new tool. Another security. Here say all securities are handling in its own server, right? Because of this, security will increase here and scalability also will increase. Now, I hope now you will you understand why MCP exists. Now, we'll understand what is MCP. We'll look into the definition of MCP. What is MCP? MCP is a open standard protocol that helps AI applications to connect to the tools or data sources in a clean and structured way instead of building everything into the application itself. In single line, MCP standardizes how LLMs interact with the outside world. In the MCP, M stands for model. Model examples are GPTs, Claude, or any AI system. It is responsible for understanding the user queries, decide what actions to take. Next, C. C is context. Context means data, tools, and prompts. Model with context. It, our model becomes intelligent and actionable. Next, P. P stands for protocol. It is a communication layer. Uses this JSON RPC 2.0 standardization. It makes sure our communication will be secure and structured. MCP architecture. At its core, MCP follows JSON RPC based client server architecture where host application can communicate to multiple MCP servers. MCP host, where an AI application is running and the user can initiate the communication using MCP host. Example, Claude desktop, Python code having LLM logic, IDEs, etc. MCP client. MCP client lives in the MCP host and it acts as a protocol handler, manages the communication between MCP host and MCP server. It sends the request and receives the response using JSON RPC. MCP server. MCP server is a lightweight process. MCP server is a lightweight process and it exposes tools or resources or prompts over MCP protocol. These tools, resources, and prompts called as a building blocks of MCP server. Now we can understand how to use these tools. Tools are used when AI wants to do some actions like write, send, create, or execute. Examples: book movie tickets, get weather data, query the database, sending the email notification. At the time, we can use the tools to perform these actions. Next is the resources. Resources are used when AI wants to get some information, getting the file metadata, getting the logs information, database records, and reading the documentation, getting the system information, system status informations. One thing here note is resources are read-only sources. Next, prompts. Prompts are predefined templates. Using prompts, AI understand how to respond or behave. Example, summarize these documents, generate report in this format, answer like a support agent. We will understand this with one real-time example. Let's imagine customer support AI agent. In this case, tools are used to open a new ticket in the help desk with user details. Results are used to fetch the past order information, previous tickets, and get the account details. Prompts helps the agents how to respond empathically, professionally, and on demand, on brand. Sorry. Now we look at the different transport types supported by MCP. What is transport type in MCP? Transport type is how communication happens between MCP client and MCP server. In simple words, transport type is the communication channel used to exchange data. stdio. Communication between the MCP client and MCP server happens via STD in and STD out. Here, one MCP server only communicates with the single MCP client. It means it is a one-is-to-one communication. One MCP client connect to only one MCP server. In this setup, MCP client within the MCP host responsible for spinning up the MCP server as a sub-process on the same machine. It is best for local integrations, CLI tools, and scenarios requiring low latency. Characteristics of this STDIO is simple to set up, secure, and ideal for single user scenarios. Next, HTTP SSE. Communication between MCP client and MCP server happens over HTTP using server sent events. Here, the server streams responses continuously to the client, but communication is one way. It means it is unidirection from server to client. In this setup, MCP server runs remotely or locally, and the MCP client connects via the HTTP endpoint to receive streaming responses. It is best for streaming LLM responses, live updates, notifications, read-only interactions. Castix is easy to implement, support real-time streaming, but limited interactivity, no bidirectional communication. SSE is unidirectional, meaning the data flows only from the server to the client. But this HTTP SSE is depreciated in the latest MCP communications. Now latest is the streamable HTTP. Communication between the MCP client and MCP server happens over HTTP with bidirectional streaming, allowing both the client and server to send messages continuously. In this setup, MCP client connects to the MCP server via persistent HTTP connection, enabling full duplex communication. It is best for agent tool calling, multi-step workflows, complex inter complex interactive applications. The characteristics of streamable HTTP supports two-way communication, highly flexible, enables real-time actions, but slightly more complex than SSE. Streamable HTTP modernizes remote MCP access with a single endpoint architecture, supporting both the request response and streaming patterns. It's the recommended transport for web applications and distributed systems. All right, we have now completed the theory part of MCP. We understood what MCP, why MCP needed, MCP architecture, and also we looked into different transport types, right? Now it's the time for the practical demo. In this section, we will build a Hello World MCP server from scratch. Before writing the code, ensure that Python and pip installed on your system, as they are the prerequisites for to run the code. In my system, installed versions are Python 3.14 and pip 25.2. I'm creating the project folder MCP underscore YT underscore demo. Sorry, spelling wrong. Changing it to the directory. Now create the virtual environment and activate the environment. After activating, you should see this in your terminal. Now installing the MCP package. I'm installing MCP package along with the CLI support. Yeah. Installation completed now. Now we will validate our installation with this single line Python code. If you see MCP installed OK on your terminal, then we are good to go. Now I am opening the our project folder in Visual Studio Code. Create the hello server .python file. Now we have to import the fast MCP module. It is a high-level SDK wrapper from the Anthropic. It handles JSON RPC protocols and other uh, server-related tasks. Now we have to create the server instance and we have to name our server. I'm giving name as Hello World. This is how our MCP client identifies our MCP server when they are connecting to it. Next step is we have to define the tools and register our tools with MCP server. For that, we have to first we have to define our function. First, now I have created the one say hello function. It accepts the name as input and returns the greeting message. hello and name. Welcome to Fast MCP. Now we have defined the tool. Next step is we have to register this tool with MCP server. For that we have to use the decorator mcp.tool. Now our tool is registered with server and name of our tool is say underscore hello. I am providing doc string here. It helps the LLMs read the description of our tool. Next, we'll create one more tool. It accepts two integer numbers and returns the sum of those two numbers. Same way, I'm doing one more. It will return the our system information. Then now we have registered three tools with our MCP server. Next step is we have to run our server. With mcp.run, we will run our MCP server. Here default transport type is stdio. Next, we will test our MCP server locally on on this Visual Studio Code terminal. But before that, indentation issue. Yes, yeah, now done. Before this, I'm running this code on Windows, right? Here, we need to add one small fix here. Encoding configurations. Yeah. Yes. Now I'm running our MCP server. It is waiting, right? It is waiting for some inputs. It means it is now our MCP server is good. Press Ctrl C to stop this. Now we will test our hello world MCP server code with MCP inspector. What is MCP inspector? It is a debugging and testing tool from MCP. It provides the UI based testing environment. For that, we have to run MCP dev our Python MCP server file. Yeah, it started. Now you will look into this inspector. Transport type here is stdio. Now I'm clicking on connect so that our MCP inspector will connect to our MCP server. This MCP inspector will act as a MCP client. Yeah. Now this MCP inspector connected to our hello world MCP server. You can see that here. This is we have not defined any prompts and resources, right? We'll check the tools. click on list tools. It will provide the list of tools available on our LOL MCP server. Say hello, add numbers and get platform info. And you can see description of our tools also it is showing here. Click on say hello tool. It is asking the input tool name. Provide the name. I'm providing my name here. Next, run the tool. Run success. We got the response. Hello, Praveen Kumar. Welcome to Fast MCP. Next, you can see all the history here. Say hello. Before we got the response complete. Same. Everything we can see in the history. Next, we'll test the add numbers tool. We have to provide two integers. Run the tool. It's success. And we got the result. Next, we'll test the platform info tool. It does not require any input parameters. Directly we can run this tool. We got the response. Running on Windows 11 with the Python version 3.14. We got the response. So our MCP server code is working fine. I'm going to disconnect. Next, we'll see how to test our MCP server code with Claude desktop. First, we need to edit the Claude config file. First, open the Claude desktop. Go to settings, developer, edit config. Here we have to provide our MCP server details. Done. This is the path where our MCP server code exists. Save the config file and we have to restart the Claude desktop. For that, go to file and exit. You see, we are getting some errors. Open developer settings. To see what's happening, what then? For that, click on the view logs. Go to end. No such file or directory. Okay, I got it. Open with Visual Studio. Here, our server name is hello underscore server, not type. We'll restart again the Cloud desktop. Yes, now it's restarted. We are not seeing any errors. Click on Customize and Connectors. Here you can see our tool is visible here. Hello, click on that and we can see the list of tools from the MCP server. Now we'll see how to test these tools. Go to chat window. Here and provide say hello to Praveen using MCP tool. Enter. Yeah. Now we got the response from the MCP server. Hello Praveen Kumar, welcome to Fast MCP. Next we will test another tool. Now we got the response for the add tool. Next, check the platform info. Now we got the response. Running on Windows 11 with Python 3.4. Now is how to test with MCP inspector and Cloud desktop. We'll see. Now we will write one MCP client code. Now go to Visual Studio and we'll create the hello client.py Python file. Already I have the code written for this. I will import all the and I will explain each and everything. First, we have to import few modules. Async IO, it helps for asynchronous programming. Client session, it will create the client session for handling the MCP and JSON RPC protocols. stdio server parameter, it will help to launch our MCP server. Next, stdio client, create the session with stdio transport type. Next, it is required for if you are running on Windows, we have to write these parameters to fix some encoding issues. Next, here we are configuring the server parameters to it will launch the hello server means our MCP server. While discussing transport types, stdio transport type, I mentioned MCP client is responsible for launching the MCP server. You remember? Same thing. It's happening here. Next, these two lines of code, it will work in two layers. First layer 1, it will launch the our server. See, we are passing server parameters. It will launch the our MCP server as a child process, and it will open the stdio, read and write. Next layer 2, we are creating the client session. It will handle the JSON RPC protocols. Next, we are initializing. Here handshake happen with the client and servers. Once handshake happen, we can get the list of tools available on the MCP server using this list tools. Just I will comment out rest of the code and we'll see what's happening here. We will run and see are we getting the list of tools from the server or not. It is connecting to server. It says it found 3 tools. One is say hello and the description of that tool is this. Add numbers, get platform info. Now we got the tools information correctly. Next. Now we are calling the each tool. For that we can use the call tool. Session.call tool says, and we can provide the tool name and the input parameters. and response will be stored here, and we are printing that. We test this single tool alone. We got the response right. Hello, Praveen, welcome to Fast MCP. Same thing. We'll run and see all at a time. Now we got the sum of the numbers at 15 and 25, and finally the platform information also we got. Now you understand how to write a MCP server, simple hello world MCP server. First thing is we have to import fast MCP, create the MCP server instance. Next thing is we have to define our tools and register our tools. Finally, we'll run the MCP server with transport types. Our MCP server and MCP client both are running locally, right? That's we are not providing anything. It transport type will be stdio. We also seen how to test with MCP inspector these tools and allow client also. Allow client, we are two things we are opening. One is for launching the server as a child process. Next, initializing the client session with handling the protocols. Next, handshake is happening. Once handshaking successfully happened, we can get the list of tools. Then we can call those tools. Before I wrap up, all the code from this video, the hello server.py and hello client.py files we built together are available on GitHub. You will find the link right in the description below. This was just the beginning. In the next videos, we will build more MCP tools, connect to real APIs, and build a full AI agent. We'll also finish the series with a capstone projects where we put everything together. If you found this video helpful, please subscribe. It really helps the channel. And if you have any questions about the MCP, the code, anything at all, drop them in the comments below. I read every single comment and I will do my best to help them. Thanks so much, and I will see you in the next one.